Now that you know a little bit about scaling waveforms, triggering, and probing with 10-to-1 passive probes, let's perform some measurements again on our resistive divider circuit, but this time using cursors, which are sometimes called markers. Hi, I'm Johnny Hancock, Product Manager for Keysight Technologies Infinivision Oscilloscopes. Let's get started. So here's our two waveforms again, V in, the yellow waveform, and V out from our resistive divider circuit. What we're going to do now is we're going to make measurements using something called cursors. Now your scope may call them markers. Now one thing I want to warn you about, I'm going to show you how it's done on this oscilloscope from Keysight, but from my experience, every scope from different manufacturers, the way they operate the cursors or the markers is a little bit different. But if you can figure out the latest app on your mobile phone or how to control the latest video game, you can figure this out. Just explore and figure it out. First step, I'm going to turn off channel 2, and let's just focus on, for now, making measurements on channel 1. We'll come back to channel 2 in just a minute. In the middle of this particular scope, there's a section that says measure, and there's a button that says cursors. Again, yours may say markers. So I'm going to press the cursor button, and 4 cursors or markers pop up. This one over here, orange, is a timing cursor. This vertical line measures time we call X1. This one over here is another timing cursor we call X2. The horizontal line is a vertical measurement cursor we call Y1, and then the top one up here is another vertical measurement cursor called Y2. We can move these 4 different cursors independently. So right now the cursors, the vertical ones that measure voltage, are assigned to channel 1. That's the only channel we have turned on right now. And it says X1. Now back over here to the front panel, there's a knob, a dedicated knob next to the cursor button. If I rotate that, X1 moves. And so let's move it over here, let's say right where channel 1 crosses center screen. And then select this button in here and change it from X1 to X2. And now the knob will move the X2 cursor. And so now I have it positioned to measure 1 period of this signal. And we can read down here, it says 50.2 microseconds. And 1 over delta X says plus 19.92 kilohertz. Remember, the input is a 20 kilohertz sine wave. And so this is pretty close, but I may have not positioned them exactly. Now, if I position this one a little bit different, now it says exactly 20 kilohertz. So now let's measure the peak-to-peak voltage of this signal. So I'm going to change this button here from X2 to Y1, which is the lower vertical cursor. Rotate the knob, position it down there at the bottom of the waveform, and let's change to Y2 now. Rotate this cursor to the top, and now it says delta Y 10 volts. That's exactly what we're putting in. This is V in. And up here we can see Y1 is at minus 5.07 volts. Y2 is at plus 4.92 volts. So it's measuring the plus peak and the minus peak as well. Now what about channel 2? Let's turn channel 2 on. First of all, channel 2 is scaled too low. We can see the relative amplitude now, but for making accurate measurements, I need to expand channel 2. Now one's on top of the other, so let's offset it a little bit so we can see it a little more clearly. Go back to the cursor menu and change the source from channel 1 to channel 2. And now let's set Y2 on the channel 2 waveform at the top of that signal. Now we're going to adjust Y1 at the bottom of the channel 2 signal, which is the voltage across R2, and it measures delta Y about 979 millivolts. That's pretty close to what we expect. Ideally, it should be exactly 1 volt. There's one other thing I want to show you. Let me turn off channel 1 since we have the cursors assigned to channel 2 right now. Go back into the cursor menu. Notice this top button up here in the cursor menu says manual. That means independent adjustment of the timing cursors and the voltage cursors. There's another selection called track waveform. And I'm going to select track waveform, and I'm going to adjust the X1 cursor, and notice the Y1 tracks along with it. Wherever the X cursor crosses the waveform, the Y cursor intersects at that point. Let's change it to X2. Set it up there at the top. Now we're measuring a half a period. It says about 24.2 microseconds, about what we expect. And we're also still measuring the peak to peak using tracking cursors. The accuracy of these cursor measurements is dependent upon how accurately you position the markers on the waveform. So you should take all those digits shown in the cursor readings with a grain of salt. The accuracy is not all that much better than the division counting method. But this method of using cursors is less prone to error because the scope does all the division counting and multiplication by scaling factors for you. Remember, we have lots of technical resources available for students at the URL listed on your screen. In our next lesson, we'll be learning how to perform measurements automatically. See you in Lesson 6. Go Virginia State Trojans!